I'm going to go down my list here. Still sharing my screen, it looks like. That's good. So grades are in Power School, and you have two blocks in Power School. And I'm just putting the grades in block one. If you've gotten everything in and you've completed it, you've got 100%. So that's your grade. And if you have less than 100%, it means either you haven't turned something in or you've turned something in incomplete. Regarding the incomplete stuff, so the chess pieces, if your chess piece just was missing some things, was you know what I'm talking about. If you want to do that, you can fix it up. I can help you when you're in school, especially probably in block 2 sometime, or we can remotely get together if you want to. I can share my screen and show you how to do stuff if you want to get a better grade on that chess piece thing. The people with just outright zeros, you can still turn those things in. I'll give you up to 90% for turning them in, but you need to get that stuff in. And I'm not going to guarantee that you'll always get 90% of stuff's late. If people are just not doing anything, I don't know. I may want to have a bigger stick for that. Oh yeah, and if there's something going wrong, your computer's not working or whatever. There are all kinds of reasons why you legitimately couldn't get this stuff done on time. Just let me know, and I'll be understanding. Please don't take advantage of the fact that I'm just going to assume that you're being honest and a good person. So I don't know, just be honest, and I will assume that you are, unless I start to get to the point where I'm suspecting that you're just not. Let's see. Attach your paper projectile log in the engineering log assignment. So I think I mentioned last time I'd like you to share that with me, and hardly anybody did. I want to be able to check in on your engineering log for your paper projectiles, and to do that, if you go to classwork, I think you're able to actually attach something but not turn it in yet. So in this intro to iterative design, the engineering log paper projectile contest, where you're supposed to make a copy of this Google Doc, just go ahead, and if you can do this now, that would be good. You don't have to turn it in, but attach it. So when I was teaching earth science, a lot of people would, and it looks like I see Owens and Davids and Jacksons, Elizabeth, so those are there. The rest of you, if you can attach that here so I can take a peek at it, that would be nice. I just want to partly make sure people aren't loading it up with stuff at the very end, because you're going to forget what went on. And partly so I can say, wait, you're going down the wrong road, you're missing some stuff, so that when you do turn it in a couple weeks from now, it'll be good. So it's there. Load the STL files. I don't know if I want to do that yet. So I've got Cura opened up here. This is the interface between I think I showed you this, between the 3D printer and and my computer and the STL files. So in just a few minutes I'll put your STL files on here so you can see what that looks like. Some of them are kind of funny. I was able to fix a few, but some of them you're going to have to fix. And some of them, like I said, weren't even turned in. But we'll get to that in a minute. Projects, I think, okay, so capstone projects. People wanted me to tell you about some past projects, and I was hesitant to do it right away before you. Oh, by the way, your project idea assignment's due today, so I haven't checked those yet. But I was hesitant to do it partly because I don't want to get you thinking about a particular thing. I want you to have an open mind before you start thinking about this, but also because the projects just haven't been very good. So there was one full year where I've taught this class. Mr. Chase taught it before me. We had one full normal year, and then last year was not a normal year. So last year, projects kind of stunk. Is it stank or stunk? Anyway, they weren't all that great because we really got going on them about the time the pandemic kicked into high gear. And the year before that, they just weren't very good either. So let me list some ones, and I'll comment on them. I've got my list right here. In fact, let me, so you have something to look at. Here's my list. So Aquaponics, this was, I don't know if any of you remember Ethan Booten was working on this. He was going to make this tank with fish in the bottom and plants on the top, and it was going to be kind of this living system. And he never even got, he didn't even get water in the thing to keep it from leaking. So just really didn't, it kind of fizzled. Robotic arm, this was Jeremy Brennan, and the robotic arm thing didn't work at all. He ended up, in the end, he had one of the coolest projects that year, which was basically a lamp that he could turn on and off with Bluetooth using his phone. I mean, that was one of the best. Heated roads. Somebody wanted to make heated roads, and there was a piece of the concrete around in the classroom and jumped to asphalt. And I don't know how that was going to save the world, but anyway. The fire tornado lamp, this was not really, it's not a global problem that we don't have fire tornado lamps, but this really what did have some cool possibilities. If you could buy a little, just like a candle that would have twirling fire going up instead of a regular flame, I thought that'd be cool, but he didn't quite make it work. Solar water purifier, that was, I'm forgetting his name now. Anyway, that we got as far as a prototype with no water in it. Floating gardens, this was kind of neat. Peregrine Ibarra thought, he was thinking about Lake Champlain and the phosphates and things that are going in there, and the algae blooms, and what if we had floating gardens like they have in some parts of Southeast Asia. There are these mats of plants floating around, and you could grow stuff that you could sell and eat, and they could also take in some of the nutrients that are causing those algae blooms. But he never got a plant to grow, never got a garden to float. He did get some experience with fiberglass resin, which is really stinky. Plastic bottle doghouse. This is another one that it ended up being a wall of plastic bottles kind of encased in concrete. so she got as far as one wall of the doghouse. Microscope iPhone adapter seemed like, I thought that this is going to be something somebody can really do. There was a guy at UVM who wanted to take pictures of, I feel like it was pictures of urine. He did something with nephrology, and he wanted to be able to, he wanted to be able to hook his iPhone up to a microscope. Just easily pop it on a microscope and have it take a picture. And it's hard to get it all lined up like that. So that one still seems like a possibility. And one thing I've always wanted to do is be able to take pictures through my binoculars with my iPhone. I can do it, but it's really hard to adjust, and so that might have had potential, but again, she wasn't able to do it. Water bottle generator. This was supposed to be a water bottle that you kind of swish around and it generates electricity. And it ended up being a water bottle that you pour out with a little water wheel on the end. Didn't generate much electricity. The shoe tracker. This was a way to track kids if they don't have iPhones. That one got going, that was fairly well formed by the end, but it didn't actually work. Video games, so this was somebody who had ideas, and then I just scrapped them all and made some little video game about gathering trash in the ocean. Power monitor with LCD putting power. Oh, okay, so this was sort of a good one, although I've seen this somewhere else. There was an LCD screen. This was Isaac Olson who made this, and he had a device that you plug into the wall, and then you plug something into that, and the device measures how much electricity gets used by your computer. So this is an invention that's already out there. If I want to figure out how much power I'm using, or how many joules of energy I'm using per day on my laptop, I can plug my laptop into this thing that then goes into the wall, and it measures electricity usage. But he wanted to not only do that, but also give you little messages. Like after I've been typing for an hour, it'll say, you know, you've just used a, 1 toast's worth of electricity. You could have toasted a piece of toast instead of done what you were doing. So that was the idea. And he did actually get a little bit, he did do a little bit with this. I'm not going to name names here, but I know this. I can picture this kid sitting there pretending to be working on his lockbox, but really just playing video games. And then he would get out this keypad anytime I would come by, and he would say, it's not working. I can't get it to work. So he wanted to make, essentially, it was going to be a locking wallet, and then it was going to just be a box and with a lock. But he never could get the Arduino keypad thing to work. All right, I got to go faster. So we had this is last year, water generator. Remember I said water things, stay away from. This person made a bunch of different propellers and turbines in CAD. So I guess that was worthwhile practice. An underbody washer for the car, again, water project, never got going, required water and pressure. The writing box, I never really understood. It was just, I think it was supposed to be an Arduino controlled box that would prompt you to write, because this person wanted to be a writer, but just could never really get around to it. So the box would just spit out messages every now and then and say, time to write some, or you've been writing, I don't know. I don't remember how it worked. Remote control 3D printed boat. That just never really got going. Affordable housing in snow piles. This was kind of cool. Somebody thought, all those snow piles in the winter and all those homeless people, what if they could just burrow in the bottom of those snow piles? And we could make some kind of supporting structure. So they'd be insulated, they'd be out of the wind, and they could be living under the snow piles in those vacant lots. So it's a win-win. But I don't know, that fizzled with the end of winter and the pandemic. Dog food dispenser. This kid, I mean, it seemed like it was like the cat food dispenser, except there was a hopper, and then there was a bowl down here, and he just got really hung up on the way the kibbles would come through, and there was some kind of a paddle wheel type auger that would spin around like this and release the kibbles. He just never could get a kibble to fall through. Months of work, no kibbles fell through. The snowblower Roomba, this was the worst one. I mean, it was beyond the scope of what these kids could do, and it was the least capable people in the class just thought, oh, this will be great. We'll make a Roomba, except it's going to be a snowblower. We'll just unleash on our driveway. Magnetic sensors to control things. So the idea was you have a glove, you put little magnets in the finger, and you just, do this, and you can control video games and your mouse and all kinds of other stuff. But again, magnets, stay away from those. Ski binding, this was one of the best. This was Nick Mendes. I can't remember what was special about the ski binding though. I tried to look at his log yesterday and figure that out, but he really put a lot of work into his ski binding and did a lot of good CAD stuff. Raspberry Pi video game, that was too hard for the person who wanted to do it. Automatic plant watering system seems straightforward, but he never got the moisture sensor to talk to the Arduino. Magnetic motor for free energy. This was one of those, Mr. Chase and I just shook our heads, but the kid was really stuck on it. He never made free energy. And then the DNA model learning tool. That was Henry Wu. He actually did quite a bit on that, but I don't think he ever got a totally finished model. So, for what it's worth, those are things people have done before. And if I had to pick one that was the best one ever, I don't know. It might be the shoe tracker, even though it didn't work. Probably just in terms of effectiveness, it was that lamp that the kid turned on and off with his phone. So, it's the weakest part of the class in the past, and I'm hoping for better this year. And let me show you, I was trying to brainstorm how I will try to help this be better. Felt like I thought of another thing I want to add to this. So this is not what I'm going to grade or base your grade on. This is just I want to turn this into a contest because I feel like that's more motivating in a lot of cases than a grade. And your grade is just going to be based on whether you complete all the assignments, basically. It can fail. So whoever wins this contest and whoever can hold his or her head the highest will meet these criteria. Clarity of the stated problem. So just make sure we really clearly know what you're trying to do here. Like that writing box, I never really understood the point of that thing. Effectiveness of the design. So you state your problem, and then in the end, did it work? Like if your whole point was to turn on and off a lamp, and it turns on and off a lamp, nice, you did it. But hardly any of these other ones actually worked. So did it work? Novelty. Some of these things people did were just kind of copies. The plant waterer, that's been done before. Heated roads, I think that's probably been done before. They do that at ski hills. Quantity of documented problem solving. The more problems solved is the better. So in the end, I think it would be really cool to see how you worked your way to your final design. That's really fascinating, I feel like. So quantity and quality. You should have evidence of you running into a lot of little roadblocks and somehow finding your way around them, and ideally in a clever manner. So if you just don't know how to be clever or ingenious or creative, I don't know how to make you clever or ingenious or creative except to just say, come on, you can do it. Or maybe you can't, but try. And so I'm not grading you on that, but if you can be, you're going to get some good positive feedback. If you can't be, I guess you'll get some good critical feedback, but I won't give you a bad grade. Completeness of the design. Is it ready to go into the world? Like, is this something you could start selling people now, or you could give to people and they could use? That's kind of like effectiveness, but I feel like it's a little bit different. And then this overall cool factor. And other ways to do that. Does it spark joy, to use Marie Kondo kind of verbiage? Just when you watch somebody present it, is it something you just get interested in? And that's a hard thing to quantify, but I'm going to try to quantify it. And then finally, at the end, all this needs to be rolled into some kind of a presentation, and it would be nice if that's just not a mess and people could look at it and digest what you did and understand it. So again, this isn't going to be, these are not exactly grading criteria. I'll give you those later. The grading criteria will mostly be meeting deadlines and things. This will be how you will receive feedback from me, and we'll decide on a winner and maybe a runner-up and a second runner-up. And then not everybody will get a prize. It's one of those, it's like old school. You don't get a trophy for participation. So let me go back to here. So those are the criteria for, really, to me that's more important than the grading criteria at this point. Keep in mind that you can, as far as I know, until I tell you otherwise, count on ordering $50 worth of stuff. And I want to go to the calendar. So there's a deadline tomorrow, which really is today for you. And that deadline is the ordering deadline for anything other than Amazon or Lowe's. We have an Amazon account that we can use. I can just stick the remaining money for this class into that, and then we can order things from Amazon. But if we need to get things from other places, like he mentioned Adafruit, there's another company called Spark Fun. Basically anything that's not Amazon or Lowe's, you need to get that order in today. So on my class calendar, there's a link to this spreadsheet, and if you want me to order something from any place that's not Amazon or Lowe's, fill this out today. And just if you have questions about it, let me know. If you want to get if it's something you can get from Amazon, which is just about anything these days, we can order it later. And I think one of the deadlines.
So you only need to do that.
Yeah,
you only need to do that if you need something other than Amazon or Lowe's.
right, and if you already know what your project is. So I doubt many people do. I haven't gotten the impression that anybody or many of you are really like set on what you're going to do yet. So I'm just sharing that with you because that's an externally imposed deadline that we have. But I'm fine with you spending some more time thinking about this. You really probably should. Look at the calendar. So stuff coming up. Gold group finishes projectiles and competition on Friday. 3D parts are handed out. So here's, let's see, where are we? Today's the 14th, so we're right here. List of capstone project ideas. Make sure you get that in today. I'll look at it just to get you and force you to think. 3D prints. Doesn't really say that, but I'm going to stick them. I'm going to load them in the 3D printer probably by around noon. 3D prints should be complete tomorrow. Nobody will be there, but I can give them back to the gold people on Friday. And if the blue people want to come in and get theirs, so you can have them in your hands before spring break, we can arrange that. If you miss the deadline, so your STL file's not done, you can get those to me tomorrow, and I'll try to start a new batch if I can, so that you can have your parts by Friday. Paper projectiles, completion, competition. The way I see this going down is that we'll probably spend block 1. You can have that to practice more and try stuff and make last minute changes. And then in block 2, we'll do the actual competition. So I think I'll probably wait. So the tape, you're just going to have to, I'm going to trust you that you're not using more than 10 centimeters. And then I'll put it on a balance and I can get overall weight so I can see if it's heavier than a piece of paper. Again, just don't cheat. So we'll do the competition for the gold people then. And then there's some run, fight, hide slides I forgot to do with the blue people. And then I'll give you back the hang time projectiles, hopefully the 3D printed things. I don't know if we'll have time to test those, but you can at least see if they fit together or throw them up in the air or whatever. A little time to work. And then blue people, basically you're going to be doing the stuff that gold people are doing this Friday on the Tuesday after break. And that will have been the third day you would have had to work on the paper projectiles. And for the gold people, the third day is going to be on Friday. And we'll wrap that up. And then somewhere way down here, this looks like way down here, but this would be the week after break. So the Wednesday after break, the projectile log is done with 3 days worth of documentation in it. Another thing that's coming up, next time we have a Google Meet, right here, prepare an up to 2-minute presentation about your chosen capstone project. So I'll have all of you, I'll give you permission to share your screens. We'll just go around the rectangles and tell people what you're going to do. Just give them your elevator speech or whatever you call it. Elevator pitch is what people call that kind of thing. The orders will be due then. I've also added a couple of assignments. These are going to be due the Thursday after break. Another tutorial. Tried to keep it a little simpler, a little shorter. I even broke it up into 2 parts. First part is designing a little laser cut box with box joints. This is the foundation of designing things with the 3D with the laser cutter. Little joints that fit together like this. And then not only do you have to design it, but then there's this additional tutorial where you take it apart, lay it flat on a plane, and then make a 2D drawing of it, and that goes to the laser cutter. So then you can actually cut out your box later on. So those are in Google Classroom. Let me get back to here. Yeah, so does anybody have questions before I open up put your parts in the 3D printer? 3D printer.
Mr. Stickton,
Yeah.
I created 2 STL files. Is that okay, or
I
you
saw
only
those.
allowed
Yeah,
to
no,
do
we'll look at them now. And if anybody has
All right.
questions about other things, just let me know. So this is the S5. This is the big one. and I'm going to start putting your files on here. I've downloaded them. So some of these, I realize what's going on. I don't know which one you wanted to do, David, but let me open this one up. And David's has a little scaling issue here. It's a little small. And did you want the block to be in there? Or did you mean to get rid of that? Oh, sorry. David?
I thought you said it's supposed to fit on a 2.25 by 3-inch bed area.
Yeah, yes,
So
but
that's what the block is.
okay. So couple of things on this one. Send me this again and then email me when you're done. But delete the block before you make the STL file. And these parts look good. One thing I can do is I can scale them. I'm assuming this is in inches, and that's what's going on. So over here, I can do uniform scaling, and I can do 25/40, and that's probably about the size you intended. This looks a little fat. I don't know what this thing is, but anyway, there's that. The other one that you got me is also too small, and it's sideways, but I can fix that. So if you want this one, having trouble clicking on it. Actually, it's my computer being laggy, probably because I'm trying to do too many things at once. But we're almost out of time here. Come on. Well, earlier when I wasn't trying to